Today is yet another day that the molecules will stick to you. Due to the forces in between all the other species like O2. They might be just the weakest intermolecular bond out there, but they don't care.
Electronegativity is the ability of an atom in a molecule to attract electrons to itself. It increases across the period and up a group. Across the period, it has the same electron shielding but more protons, and up a group it has less electron shielding. The least electronegative element is francium, and the most electronegative element is fluorine.
Negativity is a lot like tug of war. The higher it gets, the more it can pull. Electrons are pulled without making a sound. If you increase across, you decrease down. Affinity. Electrons gained, energies release negativity. Electrons are pulled easily. Ionization, what it takes to lose a charge. Radius, if the atom gets smaller, large.
This right here is my bond.
An ionic compound is when a metal and nonmetal bond together, and because of the difference in their electronegativities, it becomes very polar. An ionic bond is when two or more ionic compounds, it's when their opposite poles attract.
A hydrogen bond is a chemical bond in which a hydrogen atom of one molecule is attracted to an electronegative atom, especially a nitrogen-oxygen or fluorine atom.
An ion-induced dipole is when a positively charged ion, such as Fe2+, attracts the electron cloud in a nonpolar molecule, such as O2.
A dipole-dipole force is the force of attraction between the positive end of one polar molecule and the negative end of another polar molecule.
An ion-dipole bond is when a positively charged ion is attracted to the negative end of a polar molecule. For example, Na+ would be attracted to the negative end of H2O, which would be oxygen. London dispersion forces are when two nonpolar molecules bond to each other based on the position of their pockets of electrons.
For this lab, we needed milk, food coloring, and dish soap. The key to this lab is that dish soap has a polar and nonpolar end. When dropped into the milk, the polar end associates with the water in the milk, and the nonpolar end attaches to the fat globules in the milk, which pushes away the food coloring, causing the swirling.
LDF London dispersion forces. LDF London dispersion forces emitted from every molecule results from the constant motion of electrons in the creation of instantaneous dipoles. And they're the weakest of all the forces, causes molecules to condense into liquid or solids. The quantum forces created by electrons, repulsion of two molecules. Dipole forces. Dipole forces made from polar molecules, stronger than the LDFs, created from the electronegativity that happens from unequal sharing. Two H2O molecules are dipole forces, positive and negative partials. They do attract. This is where the dipole force comes from. Exists between permanent dipoles, and it is the middle force. Now we've reached the strongest force. It is known as the H-bond. Like dipole forces, it occurs between polar molecules and has an extension of a hydrogen. Oxygen and freaky fluorine, but don't forget nitrogen. They are the key. These are